Hello everybody. So today we are going to be doing something different. We are going to be looking at an introduction to AI. Artificial intelligence is a really growing field in the tech industry right now. It has the potential to change many different types of fields, but it is a very complicated subject. So we're going to be starting with the absolute basics today, like talking about the simplest type form of machine learning or artificial intelligence. This one is called linear regression. So, what exactly is linear regression? Linear regression is a method to typically predict models. It's a type of model that you can create which is predictive. So, to give you more of an explanation of what that would look like, we have a sample data set here that we're going to try looking with. Right now, we have two different dictionaries stored as this stored with labeled as the hours studied and an exam score. So what we want to see is we have a bunch of different these are going to be our independent variables, the variables that could be typically represented on the x-axis, and the dependent variable, which is the exam score. So we could see different students. For example, this first student has studied for 1 hour and they resulted in an exam score of 35. We have another student here with an exam who studied for 2 hours and they got an exam score of 40, and so on and so forth. We could obviously add more or less data points to this list by like adding an additional, like we could add another thing, like say, oh, let's say that another student comes in with 9 hours studying. They would get an exam score of, typically we can see that the a person who would study more for an exam would result in getting a higher score, and we could see that. Although in this case, it's not exactly linear. We could see that the jump from 1 hour to 2 hours is less than the jump from 2 hours to 3 hours, because 2 hours to 3 hours was 10, but the jump from 1 hour to 2 hour was only 5. So in that regard, let's say studying for 9 hours doesn't make that big of an impact. We could say 87. Something like that. So we added another point there. Now, first of all, let's find a way to first represent this data. What we need to represent this data is we're going to be using this library called pandas. So we could do this called import pandas, and we're also going to just say PD, so when we call the functions required to create this, we can just call PD. We're also going to want to represent this in a graphical format. So to do that, we are going to use this thing called matplotlib, and we're going to use pyplot, which is a Python plot, in order to plot these data points onto an actual graph. And we'll very shortly learn what this looks like as PLT. So we got those two libraries that we needed. Now let's take a look at making our data frame. So we're gonna say df is equal to, we're gonna use pandas, so remember we imported it as pd dot data frame. We're gonna make a new data frame, and in it we're just gonna simply put our data. Try to copy paste, but that didn't work. Okay, so now we have our data frame set, but the data cannot be completely interpreted. So what we want to do is we want to, like I said, we have an independent variable access and a dependent variable access. Typically independent variables are labeled as x, so we're going to name this as x, also known as the features. In machine learning, you typically have features and a target. So we're going to be labeling the features as x and the target as y. Why is it called the target? It's because essentially that's what we are trying to determine. We want to create a model where we can determine based off of a particular X of how much a student studied, how much we want to have like a prediction target. So this is Y is typically what we're trying to find. So first of all, let's finish making the data frame. df, we are going to say, since it's a list, we are going to call it using hours studied. Let's just copy paste this. And similarly, we could put the same thing, but Y is going to be taking, exam score. So we have our X and Y columns right now. Now let's display what this could possibly look like. We are going to do PLT. We're going to use matplotlib, and we are going to plot the points using the plot function, and we are going to say X, comma, Y. Now we should be able to create, hopefully, if I am not mistaken, we will be able to run this code. And when we run this code, we just created the plot. One more final thing we need to do is we have to do plt.show, and this should create our first plot that we make. And if you can see on the bottom right, we have created our first plot. So at each specific point, it is creating a plot where we have the specific data points. plt.plot, and it creates it in this line pattern. Obviously, this is a little bit of a strange pattern for the numbers to go from this to this to this to this. If we want to see the more specific points, what we can do is, instead of just plt.plot, we could do plt.scatter, and this should create a scatter plot. So let's do this, and when we run the code this time, let me close this out and then run it, and we get our next point here. So each of these represents the individual data points that we got. First one is at 1 and 35, next one is at 2 and 40, 3 and 50, and so on and so forth, and we see the lines connecting towards them. However, as we might notice, it doesn't really make much sense for the lines to be random like this. It would make more sense if there was some underlying pattern that we could determine in between these to figure out exactly what an exam score would be, because it doesn't really make sense to use this practically. So here's where linear regression comes in. Essentially, with linear regression, what we can see is that there is an upward data trend in general, right? And we can plot this as a singular line. But we can't just plot this entire thing as a singular line, because we could take this bottom left point going up to this right point, but that might not be completely accurate. It might not be reflective of the middle hours, the people who spend the hours in the middle, right? Because it could like miss a bunch. Or we could choose these 2 points to create a line from, but then it would miss all the rest. So how will we exactly go about doing this type of linear finding a line to be more specific about what exactly it is we want? Now, what we can do here is we can do what is called a linear regression model. So what we're going to be importing right now is this module called scikit-learn, sklearn, and we want to create a linear model. What we're going to call it is we're going to import linear regression. from actually sk learn import linear regression. So from this library, we're going to use the linear regression to basically predict our specific model and figure out what it is we can do. So now let's create our model. Now what do we do here? To start creating our model, we can comment this out for now. We are going to create our model using linear regression, so all we can do is put this to start out our model. Now, to create an AI model is usually done in two phases of training and testing. To start off, to the training phase, what we can do is we could use this function model.fit. And what this will automatically do is this will automatically create our model using linear regression and a scikit-learn model. We can take in the variables that we want to train, x, comma, y, because we need to find the specific correlation to taking in the entire data set of the x column and then the y column. And what it will do is it will create a line that should hopefully be representative of the most accurate type of model for this entire thing. So let's see what the model created. We can do this by, instead, remember how we're going to copy the same thing here, but instead of the plot being x and y, instead we can use what the model did. For in the y-axis, we can remain it keeping the x-axis, but we can also see what the model would predict based off of the x position. So based off of a certain x value, we can predict what it would look like, what the y value would look like, and see what the model would say if we were to introduce a new data point. Let's say we have this 9 value here, but remember that I added it and it wasn't exactly what was in it. So what if we wanted to know exactly what? I said 87, but it could be completely different. It could be off by something. So we're going to create the scatter plot, and we are going to plot the linear regression line by taking in the x-axis and using the model that we just created to predict the value. So let's take a look. If we run this code, oh, my bad, I forgot to include, of course, at the end we need to do plt.show to actually display our graph that we just created. And there we go. So here's what we got. The model automatically, the linear regression that we automatically found the line of best fit. Now you can notice that the line isn't exactly touching any of the points, but it takes the overall trend between the lines using a process of linear regression, and we'll go more into depth on how the model exactly does this. But for now, all you need to know is that the model created the best possible line of fit to actually predict what the overall trend is. So you could see that if students study 4.5 hours, the 4.5 hours, you can see on the side, trying to move it exactly, yes, the y value would be 59.6, or a little bit higher actually. And to actually figure out like the specifics of what we're looking for, we can go back to our code. So I'll leave this up for now. Here. Now, what we can do here is also another thing that I think would be helpful for our graph to do is something that I should have done earlier, if I'm being honest. We obviously have this graph here, but it doesn't look very convincing. Like, we don't know what the graph is about, right? So we should give it a title. So before we show the thing, let's title the plt dot x label. We're going to create an x label to represent that the x label is the hours studied. Plt dot y label to show that it's the exam score. We could also give this a title, like plt dot title. We could say hours studied. No, actually, exam score versus hours studied, because typically titles are labeled by the y versus the x, so the dependent versus the x. So we could run this code again. Let me delete it just to show you guys how that the title is working. And yeah, here we go. So we got the exam score on the left, the hours studied on the right, and show that there is a correlation there determined by this linear regression model that we just created. Now, in addition to this, to find the specific values, what we can do with the model, we can not only just plot this on a graph, but we can also print out the specific values, right? So if we do print, we want to print out the particular value, and all we need to do is we can say, let's say predicted score. Actually, let's first create the prediction. So to create the prediction, we could simply make a prediction like this. Prediction is equal to model.predict. And all we need to do is in the input, we can, in the double list, we have to say, since we are taking the prediction of what type of prediction do we make. Like I said, we want to predict based off of the hours studied what the exam score would be. So let's say instead of 9, let's say 4.5, like we were checking earlier, 4.5. If we do 4.5, what will the prediction be? We can do this by saying print predicted score and we can simply say comma prediction of 0, which is the first element of the prediction. Is the first element in this prediction list. This one automatically creates a prediction list of a bunch of different details, but what we want to find is what the predicted score is based off of a student who studied for 4.5 hours. So we could run the code just as we did earlier. Whoops. Let me exit out of this, and then okay, so we created the graph once again, but we had some issue because the linear regression model didn't predict the there was a warning properly. So it said something in the ballpark of 60 point, but I think there was some floating point error which caused validation error, user warning. I don't think we named the feature properly. Okay, that is a little bit of an issue that we will address shortly. Instead of saying 4.5, if we put a whole number like 9, yep. So if we put a whole number like 9, we can actually get a full result, because right now the model is only properly fitted for like actual what do you call for integer variables. But with an actual decimal floating point variable, the code right now has some trouble. So we can see that when we add a student, for example, with a student of 9, our model will automatically give us a new predicted score of 93.214. So, does this mean that it's guaranteed that a student who studies for 9 hours based off our data set would have exactly a 93.214? Not exactly. Like I said, none of the data points go exactly on this linear line. So there are some limitations to the linear regression model. It's mainly for a type of data set where you can see that there is clearly a linear trend between two different variables here. But in a circumstance like this, where clearly studying a student studying more results in a higher exam score, it is safe to say that there is a very strong correlation, and that this model would be fairly accurate to the student who would be studying more and more. So the linear regression model, although having some limitations, is very useful for predicting certain outcomes for students, or like data points that aren't necessarily already in the data already. So this is the first form of artificial intelligence, as it is making a guess or a prediction based off of the occurring data, which a normal like if else statement type of hard coded machine wouldn't be able to do on its own without um, a linear regression model like this. And we can go more into depth on how the linear regression model actually came up with this linear fit for these specific points. That is a topic for another day. But for now, hopefully you guys all understood, enjoyed, and appreciated this demonstration. Um, oh shoot, sorry. If you guys couldn't see earlier, that it had an predicted score of 93.214. So yeah, hopefully you guys understood the logic well, and how we got to this point. And I will see you again very soon. Thank you for watching, everyone, and have a nice day. Bye bye.